everyone, welcome back. It's great to have you here today. Today we are going to revise circle theorems. Please get your pen and paper ready and make some notes. So the first theorem says the angle and the circumference is a half of the angle and the center when they are both subtended by the same arc. What I'm going to do is to create two isosceles triangles because they are radii, therefore they are equal. Therefore, if I call this angle x, this angle is going to be x as well. Angles in a triangle add up to 180, therefore this angle is going to be 180 subtract 2x. Similarly, if I call this angle y, because it's an isosceles triangle, this angle is going to be y, and this angle is going to be 180 subtract 2y. If we are going to call this angle a, angles around a point add up to 360, therefore 180 subtract 2x plus 180 subtract 2y plus a is going to be 360. By simplifying this equation, we can see that negative 2x subtract 2y plus a is 0. Adding 2x and 2y on both sides, we can see that a is 2 lots of x plus y. This is the angle and the center subtended by the same arc as the angle and the circumference, which is x plus y. Therefore, we have proved the theorem. Okay, so now moving on to the second one. Now, this is a very useful one, but really it comes from the first theorem. So this is saying that the angle and the circumference subtended by the semicircle, it will be 90 degrees. This is because this diameter is 180 degrees. And the angle and the circumference is a half of the angle and the center. Therefore, the angle and the circumference is 90 degrees. Okay, so now moving on to the third one. Now this one is saying that the angles subtended by the same arc are equal if they are all on the circumference. So what we are going to do now is to prove this theorem. Imagine we have an angle x here. Now because we know it's a half of the angle and the circumference when they are subtended by the same arc, then we know that we can draw another angle and the circumference by the same arc, and that will be x as well. I'm going to draw a few more. They are all x by the first theorem. Okay, so now moving on to the fourth theorem. The fourth theorem says if we have a cyclic quadrilateral in the circle, so that means all the vertices of this quadrilateral lands on the circumference, then the opposite angle adds up to 180. And this can also be proved by using the first theorem. Now, if we look at this angle A, we know that it's subtended by this arc here. If we look at the angle B, it's subtended by this arc here. Now, as we know, the total angle around the circle is 360. Therefore, a half of this is going to be 180. There are two cases where we have to be really careful. If we have a vertex lands on the center, now this is not a cyclic quadrilateral. Therefore, this theorem does not apply. Similarly, if we have a vertex lands outside of the circle, then we can't use this theorem either. The opposite angles don't add up to 180. Okay, so now moving on to the next theorem. In this theorem, it says that if we have a tangent line, then that means there is only one intersection. If I join this intersection with the center, that is the radius. The radius is perpendicular to the tangent line. Moving on to the next one, the sixth theorem. This theorem says if we have a point outside of the circle and we draw two tangent lines to the circle, AT is going to be the same as BT. And this is the proof. Now we can form two right angle triangle by using the previous theorem because OA and OB are radii, therefore it's perpendicular to AT and BT. OA equals OB and OT is the common side. Then by RHS, right angled hypotenuse and side, we can prove that these two triangles are congruent. That means they are exactly the same. Then we can conclude that AT equals BT. We can also say that ATO equals BTO. That means OT bisect the angle ATB. Okay, now moving on to the next one. In this theorem, it says that if a radius bisect the chord, is perpendicular to the chord. Now in the circle, we have AB is a chord of the circle. OP bisect AB. We can prove that these two triangles are congruent by using SSS, and then we can conclude that these two angles are equal. Now, because angles on a straight line add up to 180, therefore x is a half of that, which is 90. Okay, and the final one is the alternate segment theorem. And this is saying if I have an angle is subtended by the arc, and I have another angle which is to the tangent, contain this arc, then these two angles are equal. Now, when we are doing the question, it's very useful to highlight the arc just so that we can see which angles are equal. So for example, if we have this angle y here, it's created by this arc, and this arc is contained in this angle, therefore these two angles are equal. Okay, so what we are going to do now is to prove that this theorem is true. So what we are going to do is to find the center and join the point of contact and the center. We know that this is perpendicular. I can also create an isosceles triangle here. Now, because this angle is 90 degrees and this angle here is x, therefore we have 90 subtract x. Because this is an isosceles triangle, therefore this angle is 90 subtract x as well. Now this angle here at the center is going to be 180 subtract 90 subtract x in bracket, and then take away 90 subtract x in bracket as well. Simplify this expression here, we have 2x as our final answer. If this angle is 2x, it's subtended by this arc. And then we can see that this angle here and the circumference is subtended by the same arc. By the first theorem, this is a half of the angle and the center, which is x. Therefore, we have proof that these two angles are equal. Okay, now let's do some questions just so that we can see how we can apply the knowledge. So for the first one, we are told that A, B, C, D, E are points on the circle. AC is parallel to ED. Okay, so straight away we know that co-interior angles add up to 180. Therefore, this angle is going to be 180 subtract 34 subtract y. Okay, so now let's look at the first question. They want us to write down the angle x. Now, because we know angle x is subtended by this arc, and this 70-degree angle is also subtended by this arc. Therefore, x is 70. Okay, so now we need to work out the angle y. Now, this quadrilateral is a cyclic quadrilateral. That means opposite angles add up to 180. So 34 plus y plus 110 is 180. Therefore, we can work out y to be 36. Now, moving on to the second question. In this question, we are told that R, S, T are on the circumference of the circle. This circle has its center O labeled on the diagram. And we need to give a reason why OTS is equal to x. Now, it's because this is an isosceles triangle. OT, OS are radii. Therefore, this angle OTS is equal to x. Okay, so now what they want us to do is to work out the value of x. As we can see, 5x is subtended by this arc. 30 plus x is also subtended by the same arc. So by the first theorem, we know that 30 plus x is a half of 5x, or 5x is twice 30 plus x. By solving the equation, we can see that x is 20. Okay, so now moving on to the next question. In this question, we are told ABCD is a cyclic quadrilateral. So then that means opposite angles add up to 180. Now in this question, we have x and y. To form an equation, we need to solve this simultaneous equation. Now if you're not sure what to do, there is a video on simultaneous equation. Please do go and have a look. So in this case, x is 68 and y is 24. Okay, so now moving on to the fourth question, we are asked to write down the value of a, which is a half of 70, and that is 35. And we are also asked to write down the value of b and give a reason. In this case, because this is a cyclic quadrilateral, therefore opposite angles add up to 180, therefore b is 40. Okay, so now moving on to the final part. In this question, we are told that A, B, C, D are on the circle, and we're also told that x plus y plus z is 290, and we need to work out the values of x, y, z. So straight away, we can see from the picture, x plus z is 180. Okay, so start from x plus y plus z is 290. Because we know x plus z is 180, we can work out that y is 110. Now, because y is 110, x is going to be a half of 110 because they are subtended by the same arc. Therefore, x is 55. And then we can work out z by using 180 subtract 55, and then that is 125 is our final answer. That is it for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport, and we have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.